Okay, so now that we know how to calculate the margin of error E, let's talk about how we actually build that interval estimate for our population mean mu. So our confidence interval is what we're going to call this. And so in particular, it's going to be a C confidence interval where C is our level of confidence. So to do this, all you're going to do is you're going to add and subtract E from your point estimate, the sample mean X bar, where E is still equal to the critical value of Z times sigma over square root of N. And so ultimately what we're doing is we're saying the probability that the confidence interval contains mu is C, assuming that our estimation process is repeated a large number of times. So in other words, remember, this is all going back to if we do all the confidence intervals possible, then 90% of the time or 80% of the time or whatever C is percent of the time, then C percent of all the confidence intervals possible will contain this population mean mu. So, but again, the big thing to know is how we calculate this confidence interval, and all you do is it's going to be X bar minus C and X bar plus C. So it's very similar to what we did back when we did Chebyshev's intervals, where you would do X bar minus some value, X bar plus some value. Same idea. We're going to do X bar plus or minus, in this case, our margin of error E. So all the steps in order. So first thing you want to do, you want to make sure you know that you have sigma, know the sample is random, and that either the population is normally distributed or n is greater than or equal to 30. Then you want to find your sample statistics in an X bar. So remember to calculate X bar if you need to find it. It's the sum of all the data values divided by your sample size. Find your critical value, ZC or Z sub alpha over 2, using that table. Find the margin of error E. Remember, E is equal to the critical value of Z times sigma over square root of N. And then find the left and right endpoints of the interval and actually form that interval just by writing it in the notation. So remember, all you're doing is you're subtracting that E that you calculated from the mean and adding E to the mean. And that's going to be your interval, essentially. So let's actually do an example all the way through. So a survey recently found that a sample of 40 people had, on average, 130.8 friends. Let's calculate a 95% confidence interval for the mean number of friends for all users of the website if the margin of error is 16.4. So the first thing we need to do is ask ourselves, do we have sigma? So we know in this case, margin of error is 16.4. So we already have that calculated for us. So I don't need to find sigma because we've already got E. So margin of error 16.4, so that is E. So then is N greater than or equal to 30, or normally distributed population. In this case, we have a sample of 40, so we're good. So that's step one. And we need our mean. So we know the survey found the sample had an average of 130.8 friends. So X bar is 130.8. We already know E in this case, so we don't need to worry about calculating the critical value, or N even realistically. So we can jump straight to E. In this case is 16.4. So then from there we've got our E, so now we just need to find the left and right endpoint. So we can jump straight down to step 5. So we want to find the left and right endpoints and form the confidence interval. So to form the left endpoint, it's always going to be X bar minus E. So the left is the smaller number, the lower number, left is lower. Easy way to remember that, they both start with L. So X bar minus E, so in this case that's going to be 130.8 minus 16.4. And so you're going to get 114.4. And to get the right value, so right or the larger number, so to make it larger you have to add X bar plus E. So 130.8 plus 16.4. And that gives it to you as 147.2. So then to write this out as the interval, so basically what we're saying is, okay, so 114.4, our mean is going to be somewhere between the 114.4 and the 147.2. And that would be your final interval answer. So we know how to calculate the interval. Now let's actually interpret this back in terms of the problem. So the stats are good, but you've got to know what these stats are telling you in terms of the data. So in this case, what are these numbers telling us? So that's something I'm going to often ask you to do. I might ask you to interpret your results in the context of the problem, something along those lines. So what is this actually telling us then? So I'm going to give you a template. So with blank percent confidence, we can say that the population mean in this case, or whatever the parameter you're trying to approximate is, for our purposes, it's always going to be population mean. So the population mean blank is between blank and blank. Anytime I ask you to interpret something in context, it's always going to have this same layout. So if you just remember this general sentence, you can just plug the values in. So in this case, with blank percent confidence, so in this case with 95% confidence, we can say that the population mean, so what is our variable? In this case, number of friends, is between blank and blank, so the values of your confidence interval. So it's between 114.4 and 147.2 friends, or people, however you're measuring it. So always important to have those units too. Now in this case, because I already said it's the number of friends, and we're talking about friends, you don't necessarily have to rewrite friends at the end, but it's good practice if you're talking about something in different units. So let's look at another example. So a college admissions director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, the mean age is found to be 22.9 years. From past studies, standard deviation is known to be 1.5 years, and the population is normally distributed. Let's calculate a 90% confidence interval of the population mean age. So this one we have to go all the way through. So first thing we want to make sure of is, so do we have sigma? So we know standard deviation is known to be 1.5 years, so sigma is 1.5 years. And do we have either a n greater than or equal to 30? So n in this case is 20 students, which is not greater than 30. That's less than 30, so that's a no. So then that means we have to know the population is normally distributed, and we do. It tells us clear as day. Population is normally distributed. So we're good. So we can proceed. So next thing, so we need to find x bar and n. So we already know random sample, the mean age is 22.9 years. So x bar is 22.9, and we already have n is 20. From there, we need to find our critical value of z. So remember, this just goes off of the 90%. So if we know 90%, then using that table, so remember, you can either find this table in your course pack or in the PowerPoint here. So 90% we know is 1.645. So critical value of z, 1.645. So from here, calculate E. So E is equal to ZC times sigma over square root of n. So in this case, it's 1.645 times sigma of 1.5 divided by the square root of 20. And so we do that math, and we end up rounding this to one decimal place. We get E is about 0.6. So now our confidence interval is going to be, so let's find our left endpoint. So that's x bar minus e. So remember, left is lower, so make it smaller. You're subtracting. So this is going to be 22.9 minus 0.6. And we get 22.3. And our right endpoint. So right, we're making it bigger. X bar plus e. So 22.9 plus 0.6, which gives us 23.5. So we end up with a final interval. So the 90% confidence interval for our population mean is going to be, the population mean is going to be somewhere between, based on this sample, 22.3 and 23.5. And so then interpreting it now, so with 90% confidence, you can say that the population mean age of all students is between, in this case, 22.3 and 23.5 years old. So, important thing to remember about this, mu is not a fixed number. Mu is a fixed number. So remember, it's either going to be in the confidence interval or it's not. So be careful. We're not actually saying there's a 90% probability that the actual mean is in the interval. So notice, we're not saying there's a 90% chance it's in here, right? We're just saying with 90% confidence. So remember, what this is saying is that if we do this a large number of times, we collect a large number of samples, we do this over and over and over again, and we create a confidence interval for every single one of those samples, then 90% of those confidence intervals will contain our mean, our population mean mu. So we're not saying that there's a 90% chance or there's a 90% probability that the actual mean is in this interval. We're saying we're doing this with 90% confidence. So if we do this over and over and over, 90% of all the intervals will contain our population mean. So pictorially, what this looks like is each of these horizontal segments represent a 90% confidence interval for this data, for different samples of the same size. In the long run, for a 90% confidence interval, 9 of those 10 intervals will contain the population mean mu. 1 will not. That's what we're actually saying here. So now let's say that you have your confidence level C and you have the margin of error, but you want to first go back. So early in the design stage, you need to figure out an idea, okay, how many people do I need to survey? Or how many objects do I need in my sample so that I can get a desired estimate for our population mean mu? So if you want to estimate how big your sample size needs to be, then basically all we do is we rearrange the formula for margin of error, solving for n. So you get the formula n is equal to the critical value of z times sigma over e squared. Now you don't need to memorize this formula if you don't want to, as long as you know the formula for E, right? So remember, E is equal to ZC sigma over square root of N. So if we just rearrange this formula for N, so multiply by square root of N on both sides. So E square root of N is equal to ZC sigma. And then divide by E on both sides. So square root of N is equal to ZC sigma over E. And then get rid of the square root. N is equal to our formula then. So that gives you this formula. So that's where this formula comes from. So again, if you don't want to memorize another formula, just memorize the formula for E as long as you're comfortable and know the algebra behind it. But if not, you can just memorize this formula. So if sigma is unknown, so maybe you don't know what the population mean is, then you can estimate the sample size using your sample standard deviation S, as long as you have a preliminary sample with at least 30 members. So that'll give you a rough ballpark estimate to find out roughly how big your samples could be. So let's say, for example, you want to estimate the mean number of friends for all users of a website. So how many users have to be included? If you want to be 95% confident, the sample mean is within 7 friends of the population mean. And we're going to assume sample standard deviation is about 53. So same idea. So we need our critical value of Z. So ZC in this case, so 95%. So going back to that table, we get 95% is 1.96 for the critical value of Z. And then the other piece, so we know in this case our sample standard deviation, so we have a sample standard deviation of 53, so S is 53. And so then, and that's going to be about our sigma. It's going to be close enough that we can use it to estimate anyways. And then we need to know E. So E is essentially, what do you want to be within? So in this case, we want to be within, sample means within 7 friends of the population mean. So that means E is going to be 7. So remember, E is just what you're going to add or subtract. So it's how close you want to be. In this case, we want to be within 7. So then now we just use our formula. So N is equal to the critical value of Z, so 1.96 times our sample standard deviation, in this case of 53, divided by 7, and we square all of that. So when we do this, we get 220.23. Now it's important in this case to know that if you round down, you're not going to be as confident. So in this case, no matter what the decimal is, always round sample size estimates up. Always round your sample size estimates up, no matter what the decimal is. So in this case, you want at least 221 people, or 221 users of this website. So now keep in mind, this is just a minimum sample size. So you could have more than 221, but you've got to have at least 221 users in the sample.